what questions we have. So again, last class period, we went over homework 1.1, 1.2, and 1.3. So that's what we went over. So we'll start with 1.1. What questions would you like for me to work through out of 1.1? You've got plenty of time to go over any of these that we have questions on. Huh? Which ones?
My question is more like for the short answer.
Sure.
2, 3, and 4.
Uh-huh.
Did you just want us to write out the answers?
Yeah, on those, you can either attach work at the end if you need to. You can write on the homework packet itself if you need to as well. Just make sure your answer goes in the answer blank. But if you don't have enough room, then you can attach your work on the end. And some questions won't require any work at all. So because some of them are just like question 3. There's really nothing to show there because you can just use your calculator to multiply that out. So some questions, especially in the early chapters, there's not a lot of work involved. But when we get to chapters 3 and 4, there'll be a lot more, and you'll have to attach it at the end. But just make sure I can find your answers in the answer blank. That makes it easier for me. And you can write on here, take notes, whatever you'd like to do in your homework packet. Okay, so did we have any questions we need to go over out of 1.1?
Number 2.
Sure. That was the fraction question. And that's going to make us get a common denominator to combine those fractions together. Others out of 1.1 to look at. Like I say, we got plenty of time. Don't hesitate to ask questions. If there's any of them that you think you understand but you want clarification on, you can ask about those also. So anything else out of 1.1 to look at?
I spent some time on number 4.
Oh, sure. Number 4?
Yeah.
Okay. That's an order of operations problem. We can go over that one. Okay. Anything else out of 1.1? What about then 1.2? Any questions out of 1.2 to look at and go over? Were we okay with translating those verbal phrases into either equations or expressions? Are we okay with what the terms mean? Do we need to go over any of those? Okay. Which one?
Number 4.
Sure, we can look at question 4. Okay, and that's just determining whether it's an equation or an expression. Any others to look at out of 1.2?
Number 19.
19? Sure, we can add that one to the list also. Any others? Okay. Then what about 1.3? 1.3 was absolute values and more with order of operations. So are there some out of 1.3 that you'd like me to go over with you?
Number 3.
Sure. Question number 3. Anything else?
Number 13.
13. And what other ones? Did someone?
I said the same.
Okay, yep, 13. Okay. Any others?
20.
Sure. And some of these is just making sure we understand the terms and what I'm looking for answers on these. Because some of them yet we have to know what the different types of numbers are, and just some basic terminology. Anything else? Okay, we'll go ahead and start with these. Now we can add more if we need to. So if we start working through questions and you want me to add more to the list, we can. Okay, this is just kind of the starting spot. So we'll start with these, and then we'll add more if we need to. And we're going to look at 1.1 first, and we're going to look at question number 2. And this is a good question because it's got fractions. And in this course and in college algebra, we work with a lot of fractions. And we need to remember how fractions operate. When we add fractions, we have to have a common denominator. So that means that that bottom number, the denominator, has to be the same. Okay? When we multiply, we can cross cancel. And we just multiply across. So multiplication is going to be a lot easier than addition or subtraction. So let's go ahead and begin. And we're going to begin with our first set of fractions here. We work from left to right. We do order of operations. We do parentheses. And then exponents or powers or roots. And then we move on to multiplication. And then we do addition or subtraction at the end. So we're going to do our multiplication first. And we always look when we multiply if things cancel on the diagonals. So we have a 7 and a 6. Those do not cancel. The 1 and the 4, those don't cancel either. So nothing cancels. Nothing cross cancels. So we simply multiply across. So we've got 7 times 1, that's a 7. And 4 times the 6, well, 4 times 6 makes it then 24. Okay. Now we repeat the process for the next two fractions that are multiplied together. What can we do for this one? Well, for this one, we've got these 4s, so we can cross cancel these out. Okay, and that's going to leave a 1 and a 1, right? Because the 4s will cancel. You always want to do that. It makes your next step easier. If you don't cross cancel, it'll still work, but you're going to have to reduce at the end. So it's going to be easier if you cross cancel. So those 4s cancel. And we've got 1 times 1. Well, that's a 1. And then we've got 5 times 1. That's a 5. Now we need our least common denominator. So remember how we get our least common denominator. From these two numbers, we've got a 24 and a 5, right? Okay. So what's our least common denominator going to be? Well, we start with 24. Does 24 go into 5? We'll just write out our factors. Nope. Then we've got 24 times 2. That's 48. That doesn't work either. We've got 24 times 3, which is 72. Doesn't work. 24 times 4, 96. That doesn't work. And finally, we've got 24 times 5, which is what? 120, and it works. Now, you don't have to write them all out. I'm just showing you what all the numbers are. So you just took your 24, multiply by 2, 3, 4, 5, until you found it. But you don't have to write them all out. If you can look at it and tell that 24 times 5 is that 120, and that's going to work, you can use that. So now we're going to go back, and we're going to get our denominators to be 120. So now we look and we see what we need. 24 times what makes it 120? Well, that's 5. Now, whatever we do to the numerator, we also have to do to the denominator. So we need a 5 over 5. The reason for that is 5 over 5 is 1. When you multiply anything by 1, it does not change it. So that's why these have to be the same. Next, we've got that 1/5, so we'll use a 24 over 24. Okay, so that takes care of those. Now we'll go ahead and work these out, finish it out, so we can get our common denominators now. So we've got 5 times 7. That's going to be your 35. Okay, and what do we have down below? Well, down below, we have 5 times 24, which is your 120. Next one, 1 times 24, well, that's a 24. And 5 times 24, that's 120. Now, when we add, we need to make sure that we're careful and have common denominators, right? They have to have common denominators. Fractions are confusing for students sometimes because they'll try to get a common denominator when they multiply, or they won't get one when you add or subtract. And so always make sure you remember, you need one when you add or subtract. You don't need one when you multiply. So these have the same denominator. So our common denominator is going to be 120, so that's going to come down below. And then we've got 35 and 24. We can add those together. Okay, when we add those together, that's going to give you then your 59. We need to make sure we can't reduce. I don't think it'll reduce at all, because 3 won't go into either one of them. Yep, 3 is not going to go into that 59. Nothing else is in common. So that's going to be your final answer, which is 59 over 120. And I really try to take my time and go through this one, and so you would see where all the steps are. Because students always struggle with fractions more than anything else. Hopefully that helps with that one. And we'll do more of these later on as we progress further in the chapter. So next we're going to look at question 4. And question 4 has decimals. And we've got order of operations with these decimals. And this is just going to be a calculator problem. So this is what we've got here. And this is a multiplication dot. So if we want to work this one out, same as the last one, we're going to do our multiplication first. So we'll go ahead and multiply these out here. So we have 9.5 times 16.5. That's going to give you your 156.75. So that's your first one. Then we repeat the process. For that 17.6, we're going to multiply that by 12.8. And that comes out to be your 225.28. Once we've done our multiplication, what's next? We add them together. So 156.75 plus 225.28. We add those together, and we get 382.03. And you could have typed this all in your calculator and done it that way. What I'm doing here is just showing you all the steps. All right. Okay. And who do we have here?
Vanity.
Vanity. Okay, yep, I thought you were a new person here. All right. So let me go ahead, Vanity, and get you the syllabus real quick. And the homework packet. All right. I'll mark you off as being here, Vanity.
Thank you. You're welcome.
So that was question 4 out of 1.1. So let's now look at questions out of 1.2. And 1.2, we asked about question 4. And 1.2 has a lot of terminology in it. So it's equations versus expressions. What does it mean when we say evaluate? What do our different terms mean? And for question 4, there's really not much to it. And this is where you want to really be careful and read the directions. Decide whether the problem is an equation or an expression. Now, do not try to solve this. This does not ask you to solve it. What it wants you to do is just simply tell me, is it an equation or is it an expression? Well, what is the difference between an equation and an expression? Does anyone remember? The equal sign, right? Okay. So when we look at this one has an equal sign. So what is it now? It's going to be an equation. And that's all we needed to do. So for question 4, all we need to write down here is the fact that it's an equation. So question 4, kind of 1.2, because of the equal sign, it's going to be an equation. Now what happens is a lot of students look at that problem and they think they have to solve it. They begin working through what they think they need to do without reading the directions. So always read the directions, because some questions there's not much to do. Okay. And 19 is the next question out of 1.2. So what we want here is we want to come up with our expression. We got an equals here, so that's going to make this expression turn into an equation, and we want it to equal 9. So for what value of x makes the expression 1 plus 8x equal to 9? So 1 plus 8x, we want to make sure that equals 9. So it's going to be an equation. 1 plus 8x. This is an expression here, but the minute we add on the equal sign, it becomes an equation. And that's going to equal then 9. Now, we don't have choices for numbers to plug in and check, but we should be able to maybe look at it and see. If we look at it and see, we want the sides to be the same, so I would begin with just checking 1. If I check x equals 1, that's going to work for us, because if I plug in the number 1, and all I did was just look at it, say, okay, well, 8 times 1 is 8, plus 1 more is going to make it 9. When I plug in that 1, see, it's going to make it work, because 1 plus 8 times 1 makes it then 1 plus 8. And that 1 plus 8 does equal 9. So the sides do match up. And so what we're looking for our answer is x equals 1. Now, in later chapters, we're going to learn how to solve this. We're going to learn all the techniques for moving parts of this expression, equations around, and actually solving them. But this one, all I wanted you to do is look at it and tell me, okay, just by looking at it, you should see what number is going to make it work. And so 9 is going to make it work in this case. Or sorry, 1's going to make it work, because that'll make the sides come out to be 1 and 1. We've got a couple of questions also out of 1.3 to look at. And then we'll begin the next section. And we're going to begin in 1.3 with question 3. So 1.3, we're going to look at question 3. And if you're confused about any of the steps, always say something. So question 3, let's read our directions. It says use an integer or a rational number. So that means either a positive or negative number, whole number, or a decimal, because rationals are going to be your decimals that stop, to express the number representing the change. Now, integers can be positive or negative. So if it's going up, it's going to be positive. If it's going down, it's going to be negative. And when we look at question 3, it says, on a cloudy day, the water temperature in the swimming pool drops 3 degrees. Well, if we dropped 3, that means it's going to be what? That means it's going to be a negative number, right? So the number to represent that change would be a negative 3. So for question 3, our answer would be a minus 3, because we dropped 3 degrees. And I know a lot of these are very simple, and it's easy to get confused about the wording and what I'm looking for. question 13. It's kind of a critical thinking question. And question 13 says, how can you rewrite a subtraction of integers problem to make it easier to solve? And we want to give an example of this. Okay, well, what we can do to make it easier sometimes is we can rearrange the order. So sometimes it might be easier to rearrange the order. And here's an example. So we can rearrange the order. And an example of when we can do this might be something like this. -5 plus 8. Well, maybe it might be easier for us to understand this. See, if we rewrite this as 5 minus 8, because that's easier, writing the positive number first, and we can see that's 3. So what we can do to make it easier sometimes is rearrange the order. You can put them in different order, as long as the plus stays with the 8 and the negative stays with the 5. Because it might be easier to do the second one than the first one. Just the way our minds operate. Because it's easy to see on the second one, okay, I've got $8, I spend 5, I've got 3 left. So sometimes in mathematics, we rewrite things in a little bit different order to make it easier. So all you'll need to do here is just write up an example and just say, we just changed the order. So that's how we made it easier, is we changed the order. And we'll also learn that you might want to group things differently. And later on, in a later section, we'll probably get to that today, we'll talk about all the different ways we can change things around. Using the commutative property, the associative property, we can make these a little bit easier. So that was question 13. We've got one more, and there's different answers. You could combine things together differently. It's just there's multiple ways. This is just, I think, the most clearest. We just change the order because it's easier to do the positive numbers first. Question 20. For question 20, same thing as question 3. We want to represent the change as either a positive or negative integer or a rational number. Losses are going to be negative, gains are going to be positive. So the stock market lost 20 points on Monday. So we're losing money in our, we're losing points in our stock market. So that would be a negative 20. So your answer on question 20, we lost 20 points. So your answer would be a negative 20. Is everyone okay with that? If we had gained, what would it be? If we had gained, it would be a positive value. And why can these be negative numbers? Because it says we can use an integer. And what are integers? They can either be positive or they can be negative values. Are there any other questions out of the homework to look at? Out of 1-1, 1-2, or 1-3? Anything else?
16 out of 1.3.
Sure. We can add on 16 out of 1-3. And we always have plenty of time to go through these. So don't ever think that we're rushing through them. Okay, so this one is wanting us to come up with a number that makes this true. And there's lots of different answers that are going to work here. Oh, wait, am I on the right one? Sorry about that. Yep, I was on the right one. Make sure I'm on the right one here. We want to come up with a number that fits the condition. So what we've got is we've got a condition that says our number needs to be between -6 and +6. That number is a rational number, but not an integer. Okay? Now, we can come up with lots of different numbers that'll make it work. What's the difference between a rational number and an integer? Well, remember, integers don't have decimals, right? And integers are not fractions. So a fraction would be a rational number. A decimal that stops or repeats itself is a rational number. But we don't want things like 1, 2, -3 because those are integers. Also, 0 is an integer. So we want it to be between -6 and 6. We want it to be a rational number, but not an integer. So is everyone okay with that? So it's got to either be a fraction or a decimal. It can be positive or it can be negative. There's lots of different answers here. So here's some possible answers. And there's an infinite number of them. -1/2. 1.9. That's also in there. 0.64 with a bar over it. That's also in there. Okay. All kinds of other answers too. Now let's talk about these three and see why each one of them fits in that criteria. So what does it need to be between -6 and 6? All of these are in there. Okay. -1/2. That's a rational number. Is it an integer though? No. So it works. 1.9. It's a rational number. Is it an integer? Nope. And 0.64 with that bar over it, that means it repeats itself. So repeating decimals are rational numbers and they're not integers. So there's all kinds of other examples. You could do 1.45. You could do -3/8. All of those would be examples of numbers that are rational numbers, but yet at the same time not integers. And they have to be between 6 and -6. So does that answer that one? Okay. Any others to look at? Then we'll go ahead now and begin again in 1.4. And we're going to look more at order of operations in 1.4. We've talked about order of operations in the previous sections. Now we're going to hit it harder now, and we're going to do more with addition and subtraction. And we're going to learn about subtracting negative numbers, how those work. We're going to do some more with fractions and decimals also. Okay, so 1.4, again, is order of operations. And we're now going to learn about kind of the numbering system. And we're going to learn about adding and subtracting negative numbers. Okay, so let's just go through some of these. We're going to add or subtract these negative numbers. Let's just make sure we know how these work. -5, -10. We need to make sure we understand how this one works. This is a very, very easy one to work through. We need to make sure, though, that we get the correct answer. So when I look at this, I think about money and my bank account balance. So I currently in debt $5. So I decide to withdraw another $10. So my bank account would be a negative what? -15. Now, how did I come up with that -15? Well, I looked here and see both of these were negative. So we can add them together and keep the negative sign. We're not multiplying, right? We're just adding across. And multiplying, we would have parentheses. But there's no parentheses, so we just put them together. Let's try another one here. How about -10 plus 4 minus 2? How would we handle this one? These are examples here. And what we can do is we can look at these in either one big picture or the smaller pieces. And I always like to kind of combine things together in smaller sections. You could do it all at once if you want, but I usually just work two numbers at a time. And I work from left to right. So let's see what we've got here. So I'm going to work with these two. We have -10 plus 4. So I owe the bank $10. I'm going to deposit $4, so that makes my balance now minus $6. And then I'm at a negative $6 in my account, and I need to buy something for an emergency, so I have to take out another $2. And when I take out that extra $2, that makes my ending account balance a negative what? Negative $8. We'll do one more of these, and then we'll look at some fractions. So what happens when we have a double negative? And this again was an example here. These are all examples. Okay, what happens when you have a double negative? Let's say we have minus 8 minus a minus 10. Well, we've got parentheses, okay? And what we can do is whenever we see back-to-back signs like this, we have a back-to-back negative, when we have a back-to-back, that back-to-back negative is going to make that piece positive now. Because whenever the signs are back-to-back, a negative and a negative is going to make it a positive number. So now we have a minus 8 plus 10. And think about this again with money if you need to. We owe the bank $8. I deposit $10 in my account. And so that brings my final account balance to positive $2. And again, a lot of this might be review, and that's okay. We have to make sure we have a really good foundation for moving forward. Now we're going to look at some fractions. So we're going to look at some fractions here. I'm on page 60. We're going to look at question 24. So page 60, we're going to look here at question 24. We have minus 1/4 plus minus 5/12. Okay, so when I look at this question, first thing I want to do is I want to get rid of any parentheses. So I've got some parentheses here, and they're really not needed. So we're going to learn how to get rid of that set of parentheses, because that's multiplication, and whenever we cancel these signs, it's multiplication, and multiplication is always done before addition and subtraction. So what we've got here is we've got a positive and a negative, and they're multiplied together. So positive times a negative is going to keep that sign now negative. Is everyone okay with that? Because remember our rule. Just so we remember, here's our rules. Positive times a positive is a positive number. Positive times a negative, oops, I'll write that right here. Positive times a negative is negative. Negative times a positive is still negative. And a negative times a negative, when we got those parentheses, makes it then what? Positive. So these are our rules, and we use these whenever we have the parentheses. So when we look here on this one, we have a positive and a negative back to back with that parentheses. And so a positive times a negative keeps it then what? Negative, right? Okay, we just need to make sure we remember those rules. Just like the last one. Remember the last one? What happened with it? Parentheses and a negative and a negative. Well, that makes that then what? Positive. So follow your rules there. So let's go back now and finish this one out. So this is what we've got. Okay, so that positive and a negative kept it negative. Do we multiply here, or do we combine them together? Do we need a common denominator? We do, right? Because we're not multiplying, are we? What would make this multiplication? If we had parentheses here, see, if we had parentheses around it, that would mean we'd multiply. But we don't have parentheses, so we're going to have to combine these together with either addition or subtraction. So if we want to do that, let's go ahead now and come up with our least common denominator. So the least common denominator of 4 and 12 would be 12, right? Because 12 goes into itself one time, and 12 goes into 4 then 3 times. So we need our common denominator of 12. The first fraction, we need a 12 down below, so it needs a 3 over 3. The second fraction, we don't have to do anything because it already has our 12. So we're going to multiply across here, and we have a minus 3 over 12. And we have a minus 5 over 12. So what's our common denominator? I always like to do that first so we don't make a mistake. Well, we know the denominator, the number down below, is going to be 12. We just carry it over. Now look at the numerator. You don't worry about that denominator right now. Just look at the numerator. What do we have? Minus 3 minus 5. That makes it a minus what? Minus 8. Always reduce if you can. So when we get to this step, we have an 8 and we have a 12. These both have a 4 in common, so we can reduce it down by a factor of 4. So if we reduce it down by a factor of 4, then we get a minus 2, right, by a factor of 4. And 12 divided by 4 makes it a 3. So that would come out to then be a minus 2/3 as your final answer. And you want to reduce them down if they reduce. So we got our common denominators, we put them together. And remember, when they're both negative like this without parentheses, we just combine them across. These add together, bring down the negative sign. And that was question 24. We'll do one more of these, and then we'll take a short break. So let's look at question 28. We'll look at 28, then we'll take a short break. We're going to come back and look more at fractions. And I try not to lecture for more than about 45 minutes at the very most, because I know it's hard to stay focused for that long. So we're going to look at 28, and then we'll take a short break. And we're going to focus on fractions a lot today, because students always struggle with fractions more than anything else. First thing we want to do is parentheses. And we've got a positive and a negative. They're back to back. Positive and a negative. That keeps it negative. Now we need a least common denominator. So let's go ahead and get that. And the least common denominator of 10 and 8. Well, I can tell you that it's not 80 because there's a smaller one. Okay. 10 doesn't work, 20 doesn't work, 30 doesn't work, but what about 40? Does 40 work? Yes. You want to take the smallest one. You could use 80, but that's going to make your numbers larger, and that's going to add in extra work. So always try to get the smallest one possible. So 80 would work, but we're going to use 40 because it's smaller. Now we come back to our fractions. And the first one, we have a 10 down below. We need to make that a 40. So it needs a 4 over 4. The next one, we've got an 8 below. We need a 40, so we use a 5 out of 5. Now we multiply across here. 4 times 9, that makes it a 36. 4 times 10 makes it a 40. Minus 11 times 5, that makes it a 55 over 40. Okay. Now, how do we handle this one? Well, we know our denominator is going to be 40, so that's taken care of. First off, what are we going to do? We're not just going to add these numbers together because one is positive, one is negative. So what's my sign going to be? Which one's bigger, 36 or 55? 55. What's the sign of the 55? So my answer is going to be negative. And so what do we then do? Then we just simply take our 55. We're going to take away our 36. And that gives us a 19. And we know our answer needs to be negative. Why? Because 55 is the negative number. That's the way I like to do it so we don't make a mistake using the calculator. So I always predetermine what the sign will be, and then I just subtract them. That's not going to reduce down any because 19 and 40 have nothing in common. So let's now go ahead and take a short break. So we'll take about a 10-minute break. We're going to come back and we're going to talk about improper and mixed fractions. So let's take a short break. And let's meet back around, how about 9:25? So a little bit over a 10-minute break. Be back around 9:25.